In China, there's the University of Hong Kong. They have a department, a research laboratory for the physical internet. It's called a PILab. But also in Shenzhen University and in Guangdong University. And there are case studies of physical internet-enabled cases in China as well. In Europe, we've got ALICE, the Alliance for Logistics Innovation through Collaboration in Europe. The European Commission set up 33 technology platforms, ETPs, European Technology Platforms. They cover a wide range of areas from energy to food to pharmaceuticals, everything. And one of them is devoted to transport, different types of transport. Another one, ALICE, was set up about 18 months ago, devoted to logistics. And their aim is to create a more efficient, sustainable supply network using horizontal and vertical collaboration and smoother supply chain interfaces. So what they're looking at is the optimal use of assets, pooling of resources, collaboration, giving open integrated network leading to the physical internet. And the core focus is on getting information sharing, you'll be pleased about that, Bjorn, and modular logistics units. And there's 5 themes that ALICE are promoting. Now ALICE don't actually, they are there to advise the European Union on research projects. I don't know if you've come across Horizon 2020, but that's the latest set of innovation and research opportunities for companies. They've set aside about there's about 80 billion pounds, of which 6 billion is for transport over a 7-year period. And it's all to do with research and innovation. So it's a huge amount of money they're throwing at this sort of thing. And ALICE has got this roadmap with different actions by 2020, 2030, 2040, 2050. And they've got these 5 themes here that they focus on for the research. So they're going out and suggesting companies bid for various research projects in these categories. The whole point is moving towards alignment and convergence of the physical internet by 2050. So this is where we have the movie, thank you. There's an example, this is from ALICE, a film of the internet.
The physical internet is about shipping freight just like information flows over the internet. But do you truly know how that works? Did you ever wonder what route your email takes? Who owns the servers that relay your message? Or which internet provider is used by your receiver? Probably not. And you don't have to. You rely on the internet to securely deliver your message to the receiver. Imagine a world where your message is a physical object and you are the sender or the receiver. To ship physical objects, you use the physical internet. Just like the network of servers form the internet, a network of hubs forms the foundation of the physical internet. A physical internet hub sends and receives products. Products may pass several hubs in this manner. Final delivery leaves from the hub closest to the receiver. Products moving over this open and interconnected network belong to many different parties, who have in common that they are users of the physical internet. In this way, the physical internet is enabling full horizontal and vertical collaboration. Shipments are optimized for the whole network. This requires a constant quest for the perfect capacity use of the network. Physical internet cannot be realized overnight. That's why we have to develop a comprehensive strategy for research, innovation, and market deployment of logistics and supply chain management innovation in Europe. Looking to the future, these are our goals. In 2020, we'll have realized interoperability between networks and IT applications for logistics. Around 2030, the supply chain should be fully visible. 2040 marks the birth of fully functional and operating open logistics networks, all culminating in 2050, when physical internet has become our new reality. To reach these goals, more than 30 varying projects and research studies have been carried out. Let's go over some of them in detail. Take Chillon, for example. Chillon aims to improve the quality and safety, transparency and traceability of the chilled and frozen supply chain. The development of e-Chillon smart labels, combined with the implementation of intelligent packaging concepts, represents the centerpiece of the research activities. What about the Tiger project? It has provided new logistics concepts for decongestioning of EU ports, connecting sea with inland terminals seamlessly. Tiger has provided the basis for assessing effectiveness and environmental impact, identifying proper sustainability criteria and indicators, which have been applied to real case demonstrations. Tiger demonstrated 4 cases with about 20 companies involved. We've got another one, COMSIS. This project demonstrated collaborative information services for container management and ensured that such services can be used in real-world operations. It developed innovative ICT solutions to access, standardize, consolidate, and deliver information from multiple data sources and parties. Using data drawn from the entire supply chain, COMSIS provided comprehensive and accurate logistics information, allowing dynamic replanning, increasing efficiency and resources utilization. 2 demonstrations, run by DHL and ECT, have proved the ability to create a global vision on data related to containers for ocean freights, unlocking extra value by improving accuracy and efficiency, reducing terminal dwell times. The Madalushka project proposes to use a new framework of interconnected logistics, especially designed for open resource sharing. Notably thanks to open standard on load units, real-time identification, and routing through open facilities. In this framework, potentially all goods are encapsulated in smart, modular, eco-friendly, and standard unit loads, and are handled, stored, and transported as best fit in these unit loads through shared facilities and across open networks. The project ensures a global synchronization with concurrent projects in the USA and Canada within the International Physical Internet Initiative, and paves the way for a common and early market implementation at the intercontinental level. And finally, CO3. It has set up the horizontal collaboration basic tools and business models and tested them on the first pilot project. Results of these pilots show a serious decrease in logistics costs and CO2 output, ranging from 15 to 25%. Companies like Mars, P&G, Kraft, PepsiCo, and many others are implementing the first pilots. These are only a few examples, but one by one, all of these research projects in logistics are contributing pieces to a beautiful puzzle. Together, we're developing new logistics and supply chain concepts and realizing innovations for a more competitive and sustainable industry.
Right, that was the film of the physical internet that produced by Alice. And you can see how there's a huge number of projects being undertaken looking at aspects of logistics moving towards this physical internet. So the key aim is the sustainability, the triple bottom line, people, planet, profit, combined with efficiency, moving physical objects, storing it, and realizing it and using it. It's a form of logistics web, an open global system looking at physical, operational and digital interconnectivity. That's the crucial thing, with modular containers and standardized interfaces and protocols across the world. You might think this is rather far-fetched, but when you think about when you go by plane, you get a ticket, you go from London to anywhere in the world, and you go via various hubs to get there. We are the product, effectively. Think of a letter. You post a letter in the letterbox, Royal Mail collects it, but it ends up at the destination, wherever it happens to be. You don't necessarily know the route it got there or which companies delivered it for you. So there are examples of the physical internet around, but now we're looking at expanding it into more and more products and trying to be as widespread as possible. So this is the Alice roadmap, and you can see some of the projects here, but there's far more going on.